Have you ever pondered living on another world? If so, did you think it might also include an Earth-sized comet? Space is important for our future, and terraforming Earth-sized comets beyond our sun's magnetic field outside the inner system, but within the Oort Cloud. These are the two topics we will be discussing for this podcast, Ep8. Okay, Renee, tell me, what do we call these planets and comets? Though they're not in our inner system, or are they? Do we call them exoplanets? Do we call them exocomets? Or what do we call them? Let's start with that, huh?
Well, okay, first, yeah. They're not exoplanets because they're not outside of our solar system.
Okay.
They're still gravitationally bound to the sun. Even though most of them are going to be all of them are going to be well outside the sun's magnetic field.
Yes. Okay.
What we're talking about is planets in the Kuiperbelt and Oort Cloud.
Mm-hmm.
The Oort Cloud is a belt merging to kind of a sphere of comets going all the way out to some, if I remember correctly, 200,000 AU. That's an AU is the distance from Earth to the sun.
Yes.
So it extends out some 200,000 times the distance from Earth to the sun, or about 4,000 times the distance of Pluto to the sun.
Right. Okay. Wow. It would take a while to get out
beyond
there.
that, actually, about 5,000. That, for comparison, the system Alpha Centauri, the nearest system to us,
yes,
is only 270,000 AU. The Oort Cloud extends to 200,000 AU, which means the Oort Cloud is well over halfway to Alpha Centauri. That does mean that, it's being gravitationally disturbed by Alpha Centauri, but it seems to be resilient.
Okay. And of course, that's all calculable.
There's still a lot of debate over it.
And other variables which we would not necessarily know about until we perhaps send a probe out there. Wouldn't that be a good idea?
Yeah.
So that would be a project for us to send out a probe to investigate and look and examine some of these planets and comets.
Sure.
And what does it mean to be outside of the sun's
Well, hold on,
magnetic...
you're jumping ahead a little there.
Go ahead.
What's interesting is that based on the scientist who discovered Eris, Mike Brown, and his colleagues, and they're also the same ones who have discovered the hypothesized about Planet 9.
Okay.
Well,
yes.
Brown and his colleagues, they're saying that based on their data, that there could be dozens, maybe even hundreds of Earth-sized and larger worlds out there in the Oort Cloud.
Yes.
Maybe hundreds. We're not even talking about
area.
Rogue planets. Yeah. We're talking about the leftover debris of the protoplanetary disk, basically, that never formed into planets in the inner system.
Mm-hmm. Okay.
It's so vast out there that the distance from, even though there's potentially trillions of comets out there,
yes,
the distance from one planet or comet to the next could be larger than the entire width of this inner solar system. And that gets to a tricky point, is that we normally define inner system as inside the orbit of Jupiter and outer or beyond that.
Right.
But really, all of the system, all the way out to Pluto, is inner. Beyond that, you're getting into the Oort Cloud, Kuiper Belt first, and then the Oort Cloud.
Yes.
So,
I would almost venture to say that there is no distinction or separation. I think we'll eventually find that out. What do you think?
That's a yes and no, because inside of the orbit of Pluto, the number of comets and other planets thin out drastically.
Mm-hmm.
You have a couple of big ones, and that's it. Beyond the orbit of Pluto, it gets thick pretty quick. And so we need to kind of distinguish also beyond the orbit of about Eris, so it's about 70, so beyond about 70 to 90 times the distance from Earth to the Sun. The Sun's solar wind peters out, and we reach the end of its magnetic field.
Yes.
So we can use it as a marking point. If anything inside that is inner, anything outside that is outer.
Okay.
And now the thing is that a lot of these planets are going to be as big as Earth and bigger even. It's not just...
That is interesting.
Which might seem like, no, how can we miss that? These are so far away, and there's nothing but... For comparison, standing on Eris at 70 to 80 times the distance from Earth to the Sun, the Sun would just be about as bright as the full moon, and you'd see the hazy zodiacal dust disk around it.
Yes. Okay.
We'll need to put a picture on screen at this point.
Yeah, we'll do that. Yes.
So these planets, they're and a lot of them are dark in color due to that buildup of those red tholins.
Tholins, okay.
Dark red, and that makes them incredibly like Sedna. I think is one of the most distant ones. I don't think it's the most distant anymore, but it's one of the most distant planets found thus far, and it's only goes at most about 900 times the distance from Earth to the Sun out.
The amount of light out there is so minuscule. To be able to see a planet would be extremely difficult.
Yeah, we'll put another
picture.
We'll put another picture on screen there showing what it looks like from Sedna.
Okay. Yes, that'll work. Yeah.
And so the problem is that these planets, they're really dark and they're really far away. So finding them, we struggle to find Sedna. Anything further out, like 10,000 AU, 20,000, 100,000, the only chance of finding them is, even with a really large telescope, you'd have to stare at it for days and days and days, and then you'd have to try and find, is this slowly moving thing a planet? It's like...
Yeah. We would just happen to be lucky that it passes between some distant stars and the view of the
that's
telescope.
The primary way to find it, or gravitational lensing.
But we would be staring at a particular, or gravitational lensing.
The problem with waiting for it to eclipse a star, occult it's called, is you just get one image, and you're not going to find a second image after that.
Yes, right.
Because out there, it could take thousands of years, millions even, to come back around to the same spot, and like, meh.
Yeah.
So, we can entirely miss whole planets as big as Earth and bigger. And there's something I think I'm not emphasizing this enough here, is that these planets, based on the composition of some of the ones we do know about, they're not all going to be just balls of ice.
No.
A fair number of them are actually rocky, covered in ice.
Right.
And that means, well, we might be able to actually terraform them.
Something before we get too far away from what we were talking about a minute ago.
Yeah.
I'll put on screen so viewers could pause the video and go have a look, showing just how vast the Oort Cloud is. And any planets contained within that. You'll see that in the picture, our inner system is just this little tiny, it's like an ant on the surface of the Earth.
It's like a dot in the middle of the vast Oort Cloud.
Right. And so the idea that there could only be a dozen planets out there is preposterous. There is enough space and enough debris that there could be literally thousands of planets and comets. That is, when we say comets, we're referring to planet-sized comets. So
there could be hundreds of Earth-size and bigger.
There could be hundreds of Earth-size, thousands of maybe Mars and smaller.
Yeah. And trillions of smaller still.
Yeah. Yes.
And
which is another excuse me one second. Which slightly off the point, but no, actually it's very much related, and we'll cover that maybe a little bit later. But from one of these planets is a jumping off point for mining, resource gathering from all the smaller bodies out there around in the Oort Cloud. So, okay, you were saying now?
Well, so picking up on the point I started to make, and also, sorry for how
broke up it is.
Yeah.
But that's
some
good
podcasts
because
are nice and smooth and practically
polished.
Like we scripted it all. Others are, well, sort of all over the place.
Most of them are that way.
But hey, that's what a podcast is like. They're meant to be unscripted. They are unscripted, and that's part of their charm.
We haven't prepared. We have this body of knowledge, and we're sharing it. And eventually, we'll do a video on this. But
and to those also who want
discuss it.
To those who want more information, more details. For one, when we do these podcasts, we don't always have enough time to prepare to do a thorough breakdown of it like a normal video.
And they're not video replacements either.
No. So if you want more information, look up some keywords we mention, and we'll do our best, but no guarantees, but we'll do our best to actually put links to relevant papers in the video description. So please refrain from giving us too much of a hard time in the comments about not being technical enough.
Scientific enough, providing scientific information. That is what the videos are for. This is a podcast for discussing.
It's a free-form discussion.
A free-form discussion for discussing ideas, which we're presenting the possibility of actually settling and potentially terraforming.
Hold on a minute, I want to say something else.
Okay, go ahead.
I just wanted to add this. What you're hearing here with our free-form, almost rambling talk, this is how we talk with each other every day. You're basically getting a recording of something like the discussions we have. And our well thought out research ideas we do in the videos, this is how they start. So please don't expect the same kind of rigor here. Think of this as preliminary of discussing something we find interesting, that we hope you'll find interesting, and just enjoy it as that rather than putting more expectations on it.
Yeah, that's right. Just enjoy this as a free-for-all conversation of ideas. If any of you would love to see a video about this topic, let us know. Put it in the comments. Say yes.
And share the video.
You guys want to support us? You want an interstellar project? For those of you who want to be involved in an interstellar project, but for one reason or another are unable to, just by sharing our videos and our podcasts,
which costs nothing,
which does not cost you, you are participating in a small way. Oh, also, We are considering the idea of actually having merchandise, that is Interstellar Mission, AsteronX, and Iris merchandise to sell here on YouTube. If you guys are interested in such, also please let us know in the comments. Say, yeah, I would love to have something, and tell us what you would like. Yes, that would help us out a lot. And tell us what would you like to see? What would you like to have? Okay.
If you're willing and able, support us on Patreon, because relying on YouTube ad income is fickle. If a video just happens to not be super popular, YouTube doesn't show it, and we don't get any money from
our videos. Right, and our videos, a lot of work goes into our videos.
They're not we can't really bang them out once a week. We can do the podcast just barely once a week. So having a more stable income from Patreon, if we could get that up with your help, with your guys' help, that would really take a load off our shoulders, and actually will result in faster videos because we won't have to stress so much over what's going to be popular or not.
Yeah, and
we'd be able to focus on making the videos we find interesting, and you guys hopefully as well.
Well, our videos will be based upon the Interstellar Mission. But more importantly, we're not just sitting around producing videos. That's not the purpose of our videos. Our purpose of our videos is to share and to bring in a little bit of income as well, of course.
And we'll talk more about this in another video, but we do have... And we've been dropping hints for the past little while, but we do. This is all part of a much larger project that goes well beyond videos. The Planet Seeker, which unfortunately the video didn't get many views, that
no one
is
seems to think it's valid.
You guys, the Planet Seeker is actually the start of a real project.
That would be an interstellar project.
That would be the start of an international interstellar project. Just think about that a minute. We launched that telescope, and it would barely cost $100 million. Even if you were wildly conservative about your estimates, it still would cost less than $200 million. That's a bargain compared to most telescopes. Once that's launched, then actually even just beginning to get that together, that's the start of an international project to do starships now. A starship project. That means now there'd be an international team working on that, because if we're going to go anywhere in a starship, we need a destination. And the Planet Seeker would allow us to find that destination. And think about this. If a habitable planet was discovered a few light years away, even if it was 30 light years away, just think about how much resources would suddenly be able to be mobilized to build the starship. But I think that's enough about that. We should get back to the main topic of the video.
Okay, go ahead.
So, terraforming one of these planets. And first of all, I want to mention that Brown, the discoverer of Eris and one who hypothesized Planet 9, Mike Brown, he actually says that in his estimate, there may actually be a Earth-sized planet, or comet, whichever you want to call it, at around 100 times the distance from Earth to the Sun. That's not that far.
Not that far at all.
You could actually reach it with something like the Vasimir in a few years' time, and with a fusion drive, you could easily reach it in 6 months or better. So there you'd have it, another Mars, like another planet, so to speak, that you could terraform. It sounds crazy, but...
No, I don't think it sounds crazy at all, actually. Because the more you put thought to it, the more likely... the more thought you put to it, the more you see that it's not a crazy idea. It's actually a good idea. The more home worlds we have, the better. But it also provides us a jumping off point for a whole host of other things. One of which is of course, interstellar travel. And a whole host of research throughout the Oort Cloud. Wow, I mean, think about that.
So what would it take?
Go ahead.
So what would it take to terraform one of these worlds?
Yeah, what would it take?
Well, I've done a little bit of back-of-the-napkin calculation, and I figured it's like this. There's, I don't have an exact reference, but I've read before that heating Mars to about Earth-like temperatures would take only about a decade if you could somehow capture all the insolation, all of the solar energy hitting it.
Yes. Okay.
Realistically, using like CO2 or other greenhouse gases, you could capture about 10%, which means it would take about a century to heat Mars from its current temperature of about minus 60 Celsius to 14 degrees, so about Earth's average. That would take about a century.
A century, right.
That equates to an average around 1.35 degrees of warming per year. Average. Okay. Some years will be warmer, some colder. It'd probably start less, but that's an average.
Okay.
So, assuming that you could provide a similar degree of insolation to one of these Kuiper Belt planets, and by the way, Dr. Robert Zubrin actually suggested this using these artificial singularities, like we talked about in the 2 podcasts ago, and I'm going to talk on the video that is coming shortly.
Yes.
You could actually use these artificial singularities as artificial sun satellites. And you can watch the podcast or the video to learn more about that. But just assuming for a moment that you could use those to create a similar degree of insolation on one of these Kuiper Belt objects as Mars with mirrors or Earth, then assuming that, and also assuming that it has an initial surface temperature of a balmy 4 Kelvin, that's 4 degrees above absolute zero.
Yeah.
Which is...
That's very, very balmy.
Extremely cold.
Yeah.
We'll need to heat that by some 283 degrees Kelvin. So going with going with a similar average of 1.35 degrees of warming per year, it would take over 209 years to reach Earth-like temperatures. But that's not too bad in the long run.
Right.
So what it takes 200 years. That's 200 years, and then from then on, for thousands of years onward and longer, you'll have another Earth-like planet. Do that to several, and by the end of this millennium, we could have maybe at least a dozen terraformed worlds, a dozen Earths in our backyard. You might wonder, what's the point if you have FTL travel?
Yes.
Well, while we don't think that there's only like one Earth-like planet in the whole universe or whole galaxy, we still think that they're going to be rare.
Yeah.
In the whole galaxy, though it has billions of planets, well, there might be only a few million Earth-like planets.
Yeah, there could be
only a few million, and they're going to be spread over the whole galaxy, and
that wouldn't necessarily be everywhere. So,
and that's assuming they're empty.
Yeah.
The thing is that if you look at Earth, life started about as soon as it could. And honestly, I would say intelligent life, self-aware life appeared about as soon as it could. Because if you plot like the average brain size as you go through from as far as we can tell, well, my personal opinion, now it's just an opinion, but it is based on the research I've done, I'd say that it was on a pretty much constant linear trend of increasing average brain size. It's slow because, well, there's not necessarily a whole lot of evolutionary incentive for large brain size, but as it does slowly happen, well, if you're a bit smarter, you can survive conditions that maybe a dumber animal could not. A less intelligent animal might perish in some changing conditions, whereas a more intelligent one has the potential to adapt. Regardless, if that is true, and if intelligent life did appear on Earth as soon as was possible to, it would seem to indicate that most habitable planets are also going to be inhabited. If not by natives, then by, well,
Yes, by
other
somebody,
intelligent
yeah.
beings that evolved on a nearby planet.
Right.
So given that, going and creating a dozen new Earth-like planets in our backyard, even with FTL travel, would still be a benefit. And here's the thing.
And perhaps necessary.
They will outlive the sun. Because even when the sun dies, they're already outside its magnetic field. They already are so far that the sun's just a particularly bright star in the sky. And when the sun dies...
Go ahead.
When the sun dies, well, the white dwarf left behind will still have about the same mass, and it will therefore sufficient gravity to keep those worlds anchored, even though it's no longer illuminating them at all.
For those who are not familiar, the sun will turn to a red giant, and it'll come out and engulf the inner planets.
Only about Earth.
Only about to Earth.
I think Earth will survive. The models show that Earth will survive physically. Like, unlike Venus, it won't be engulfed, but it will move outward, and it will be roasted, and then frozen as the red giant.
Some may not think that roasting the planet is surviving, but what you meant is that it won't.
Well, I mean, it's not going to be physically
disintegrate.
Destroyed. Yeah.
It'll be physically destroyed on the surface, but
it'll
just
be a lava world. They'll slowly cool off.
Yeah.
But unlike Venus, which will be just entirely consumed by the sun.
But the planets
way out there, they won't care.
They won't even. They'll see a blight. They'll see a bright spot and
then that will fade away,
and that'll be it. Right.
And also, even if they do drift away, they just become rogue planets, and so what? They don't need the gravity there. They can just stay. They can sit there as terraformed rogue planets in deep space with a ring of artificial suns around them for millennia, for millions of years, even.
So
maybe even billions of years.
Or it depends on how well it's maintained, the artificial suns.
But it has the potential to be around long after our star has died. It's like, talk about long-term investment, long-term stability.
And a longer period of survival.
Who knows what will exactly be in billions of years from now, but still, we'll have the time to find out. We'll have the time to get there.
Right.
Some of you might recall Planet 11 from space battleship Yamato. It was a distant covered belt Oort Cloud planet terraformed with an artificial sun. This would be kind of similar in that regard.
So that was the thing I wanted to emphasize for a moment. How this would be done is there would be a series of artificial suns or stars heating and maintaining the temperature, the habitability of the planet. And is this doable? Yes, it is.
Hold on,
it is doable.
Keep talking. I just gotta step away a moment.
But there's also something else. Recently, and we did post this into our community tab, they've already had success at extending life by 500%, which means that we have already proven that this works. And it's only just a matter of time. What that 500% life extension equates to is between 300 or 250 up to 450 years. So any of you who might say, oh, it's going to take 100 or 200 years to terraform one of these planets. Well, if you're living 250 to 450 years, then what's it matter? And if you want to live on one of these, why not be terraforming it? But that raises another question. Would any of you be interested in settling one of these planets out there in the Oort Cloud especially if it's undergoing a terraforming process. Yes, these artificial stars orbiting the planet would have to be maintained, but it's not like I got that. Yes, these artificial stars would be maintained, but it's not like you need to go up and fuel them, because you're going to be using singularity converters, which will go on for a very, very long time.
Actually, that's a good point. Although normally they would still be refueled, like one of them that Zubrin talks about, for example, would not need to be refueled for 84 million years. But you could eliminate even that, because as I talk about in the upcoming video, there's the potential to extract limitless energy from a singularity, and you can convert some of that to matter. So you can literally make a singularity feed itself. That sounds like a paradox, but don't worry, I explain how that can be in the video. It doesn't even involve any exotic physics.
That's right.
There are papers on that, by the way.
It's not some sort of what do they? Oh, it's on the tip of my tongue. What do they call that? Where a machine maintains itself.
Over unity.
Over unity, yeah. No such thing as over unity.
The only kind of free energy that there is when you aren't actually providing the input. Like solar energy or geothermal or wind, those are technically free.
Free. The solar panels are not free.
No, but in other words, you don't have to put in fuel to convert. Like a nuclear reactor is not providing free energy because you have to put in the uranium.
Right.
But with a solar panel, it is free because you're not fueling the sun.
Right. The sun is supplying all the energy necessary. So in anything that's what they call over unity, either it's bogus or there's some other process taking place, like it's taking energy from, say, the fabric of space, which is possible, doable. There's many, many papers on that, but that's not the topic of this video.
Have you covered what you wanted to cover?
Not entirely. Let me look over here
because I do have some more things to say about how to get out there and find these.
Yeah, that was one of my questions I wanted to get to. These are going to be extremely cold and dark because there's a little bit of light.
But that's actually not quite fair, because that's only on the surface. When you're indoors, or if you're under an artificial skylight, there's that artificial skylight they made recently that was very convincing.
Well, we have
if you're under that, a ceiling of those, then it won't be any different than living on Earth.
We're going to post some images here right now, if you have a look, of what it would actually look like. It's brighter than you think.
We can also put on the screen some pictures of what this artificial skylight looks like, and we can put links to the company that.
This is not a window.
It's impressive. It looks like it's a window, but it's indoors.
There's an artificial star in the screen, and when they take a picture of it, the camera shows a lens flare, just like you were. We're also going to post
a link to to a video talking about it in the description. And if I recall correctly, in this video, let's see. Well, it's not this video, but there's another video where they're outside. It's a somewhat dim, overcast day, and then they go inside, and there's suddenly a skylight there, and it's a little funny because the skylight's like a bright, sunny day, and it's also in the first floor when there's 3 floors above them in the way. It's so funny, and yet it's that convincing. It seems like you're on the top floor, and it's a bright, sunny day.
Yes, it's absolutely impressive. Be sure and check out their website. Now, we don't have any affiliation with them. We just find it very impressive.
So do you have more to say, or can I talk about the plasma magnet?
Yeah, well, I just... Okay, we'll get to that in just a second. I do have one other thing. Think about just because you might be living on another planet out in the Oort Cloud, it doesn't mean that you cannot return back to Earth. It doesn't mean that you have to live on just one. You could actually live on or have homes on both worlds. Think about that. So why don't you go ahead and talk about this plasma sail?
Plasma magnet. Yes, so to find these worlds, we'll need more than telescopes, because even our own planet seeker will struggle to find these distant, dimly lit, often dark planets. So we'll need to actually build and launch probes to fly out there and get closer to these planets. Even a few hundred AU difference will help. The question is how, because it's very distant. Any rocket or even ion would take a long time to get out there. The answer is something called something called the plasma magnet. It's basically a kind of MHD drive in space, using the interplanetary or interstellar medium instead of a planet's atmosphere. It's similar to the magnetic sail or mag sail, except that it uses plasma instead of physical coils, basically plasma coils, to gain thrust from the solar wind. Links to a paper, original paper, down in the description. And if supplied with large amounts of onboard power, a probe powered by this could attain a speed as high as 800 kilometers a second before the solar wind weakens, which occurs around 70 to 90 times from Earth to the Sun. Yeah, that's not shabby at all. Yeah. In fact, at that speed, if you could reach that speed before the solar wind cut out, then you could actually, that would be if you were doing that as an average speed. But even if that was the speed you only reached near the end of your trip, of your acceleration period, I mean, you could perhaps reach possible Earth-sized planet at 100 AU away. You could reach it in maybe a year.
That is pretty darn good.
So using that, you could fling a probe deep onto the Oort Cloud, and it could just coast and survey planets as it flies by them. Send a whole swarm of them, and you could start to do a reasonable survey.
And did you state how I had to step away for a second. Did you state how big these
tiny
probes would be?
Because the advantage of the plasma magnet is it doesn't need a large physical sail. It just uses magnetic fields to grab a hold of some plasma, and it starts rotating the magnetic field. And the plasma flings out until it reaches equilibrium with the solar wind, creating an enormous plasma sail.
You're talking about
MHD
basically
in space.
another kind of electric motor or MHD in space.
It is even conceivable, if you had enough power, that maybe something similar could keep accelerating after it's left a solar wind, basically the same way an MHD aircraft flies in Earth's atmosphere.
Well, a singularity converter fusion plays right into that role. In fact, if you accelerate
one of these probes to relativistic velocities using like our fusion drive, our muon catalyzed fusion engine design, it could fling out to high speed and coast, and then on arriving at a destination star system, use the plasma magnet to both decelerate and maybe even collect propellant for a return trip. That would greatly reduce the propellant required. It means that maybe in the next 2 decades, an unmanned mission out to Alpha Centauri is actually feasible.
Now that would be something, wouldn't it? The beginnings of our Star Trek-like future.
If we start colonizing these Oort Cloud planets, like Todd mentioned, jumping off point, it might start to create an incentive, especially if, as we start mining asteroids, maybe we want to go further out for more materials still, because there's one estimate that showed there's one paper that showed that within the next 400 years, based on our existing growth rate, we could actually have already halfway depleted the asteroid belt. But it's worse than that, because Todd and I have been talking about this, and we'll come back to this in another video, perhaps. Or not perhaps, we will come back to it.
Yeah.
And I think we touched on this in the other podcast. The amount of material required to build a single starship, like a kilometer across, like a sphere, or even not a sphere, the amount of material you might require, and you build a fleet of these, you're going to consume the asteroid belt not in 400 years, but maybe as little as 50. You might be halfway depleted already. So we might increasingly find the Kuiper belt and Oort Cloud interesting. And that creates then an incentive structure. Settle one Oort Cloud planet, and it starts to build up and starts to become a trading hub, then mining hub, then now there's... And so you now have a reason to go out that far, and, well, there'll be an incentive to go out there faster, because the faster you go, well, you can get a hedge on your competition if you can go out there faster and more efficiently. And this might create a self-perpetuating feedback loop that will lead to us, that could help lead to us achieving interstellar travel, even FTL.
So what is it you wanted to say?
I wanted to read a little clips here of what I wrote for the website about why space exploration and human settlement of places in space is important. There's a number of reasons. There's, for one, if we could monitor the Earth from space, and we could, well, and make that information readily available to anyone who needs it, not just a few, then, well, there's a lot of things that could be more efficiently coordinated. We could use our resources more intelligently. And to give another one, there's a whole new kinds of manufacturing, biotech, etc., that we can only do in a microgravity environment. Though we'll be able to make materials to actually replace more, well, other materials we need right now. There are, for example, using, say, microscopic robots, microbots. In microgravity, we could use them to replace a lot of 3D printing. We could mass produce using those, because without the limitations of gravity to squash the poor little robots to the ground, we could use swarms of them in a microgravity chamber to actually construct things on the nanoscale, mass produce them. We could use it to make
nanoscale printing,
and also we can do things like metal foams, which are hard to make on here in a gravity field, but easy in microgravity. Metal foams would allow us to take an otherwise solid material and shave off some 50, 70, 80% of its mass without losing any strength. In other words, things like this, we could actually start to, well, reduce our material requirements. It would actually be better for the planet. We wouldn't have to mine so much. It would start helping things down here and increase the standard of living. Or another one, we start mining ice in space rather than have to haul water up out of Earth's gravitational well. If we go to Phobos or Deimos and mine it, right now, telecommunication satellites have to use low thrust ion engines, low acceleration ion engines to move around, because it'd be way too expensive to keep hauling propellant up. As a result, well, they're limited on their orbits. They put up in an orbit, and that's it. And if they have to move it, they have to raise the price to make up for the lost coverage while it's moving to a new orbit. If you could bring back huge amounts of ice from Phobos and Deimos cheaply without having to haul it up and sell that to the telecommunication companies, or some company could do that. One company mines ice, another ships it, and the telecommunication satellite buys the ice. Telecommunication company buys the ice. Well, with that ice, that they could then use high thrust engines and move the satellites between orbits more quickly, and therefore the cost of telecommunications would be shaved off. They could just throw up a empty probe into low orbit. It could get refueled in orbit and then move itself to its desired orbit, greatly reducing the cost. So that means internet and other things, other telecommunication systems become a lot less expensive. Basically, if we don't want to end up rendering Earth uninhabitable, we need to start doing mining and manufacturing not on Earth so much, but in space. And while a lot of this can be automated, our current AIs are still, they make simplistic assumptions about the world. They are still prone to malfunctioning, glitching, and there's the danger that if it's fully self-aware, it could develop its own different moral code and, well, effectively revolt. It's not it's not fiction. There's some respected computer scientists talking about that. So for a while we'll undoubtedly eventually solve these problems, in the end we can't wait. In the interim, we need to start using these automated systems, so we'll have to just make do with human oversight.
Well, the point is we don't wait until it's past tense, when it's too late. We need to start this process now, so that we don't run into. It's just like you're going down the road and you see a pile of bricks and the road fell out of a truck. Do you turn the wheel before you reach the bricks and avoid them, or do you turn the wheel at the last second?
The main point is...
No, that's not the point.
Sorry, I didn't mean to interrupt. I just wanted to keep it on the... In other words, space is important. Going out to these Kuiper Belt objects, it's important for... Not just simply because, it's in abstract thinking, a good thing to do. It's going to be vitally important to actually maintain and improve the standard of living here on Earth without completely destroying the planet.
Yes.
With resources from space, we could actually start to have a Star Trek-like future, like in that kind of abundance, that so-called utopian abundance. We could actually start to have that for real. And forget utopia. It's nothing that...
Yeah, no utopia.
Look at the... No, look at the... It would improve the standard of living to something like first world standard of living, but not just for developed nations, but for all nations. It means that humanity would really start to have a bright future.
This is one of the steps towards a brighter future.
I cannot emphasize enough how important it is. We can actually finally start to have a brighter future, finally start to improve the standard of living using the things we can do and find in space.
At the beginning of I think it's the last podcast, I stated that we need to have multiple planets, not because we're doomed here on Earth, which, sure, things are going to happen. We're not doomed. But we need to establish other planets outside so that we can maintain a future, a brighter future, forever growing. I mean, we're not just going to stay on one planet and stagnate. And we don't have to go out into space with the idea that, we're one of these days we're going to get slammed into by an asteroid. Sure, that's valid. There could be a cosmic beam to come through and vaporize.
More likely sterilize it.
Okay. Thank you. Sterilize it. But the point is that's not why we go into space. That's not why we settle other planets. We need to do it because we're growing population. If you want to go around and stop all the population growth right now, that would be inhumane.
More to the point.
Yeah.
And this is the point I was trying to emphasize on again, and I don't want to get away from.
Yes.
We can improve...
Go ahead.
Even long-term stability. We can improve the standard of living on the planet right now if we actually start going into space in a big way and developing the infrastructure out there. We could actually improve the standard of living over the whole planet immediately with that. Or shortly.
Immediate, yes. Well, shortly would be relatively, it would still seem immediately.
That's the main important point. Forget anything long term. That's important, but focus on we could actually improve the standard of living now. That's an immediate, concrete benefit to humanity for going into space. It's not, so many people wonder, well, it's so abstract, or it's a good thing to do in theory, but it actually would have immediate positive consequences for Earth now.
And throughout history, we have similar comparisons where exploration has benefited humanity. Yeah. Think about it. Give it some thought. Do you want to be a part of an interstellar mission? Would you be interested, you as an individual, in going to another system to have a look?
Are you interested in living in a future where people aren't starving anymore, where people aren't dying of thirst anymore, one where everybody on the planet,
yes,
not just a privileged few, actually have a high standard of living? Are you interested in that? What kind of future do you want?
What kind of future, indeed.
This.
Okay, well, everyone, well, thank you again for listening. We will pick up this topic again. We do have to keep saying these things throughout the video. So on that note, thank you for listening. Keep wandering about space.
See you next time.
Thank you.